Hello Gators, this is 4-2 isosceles and equilateral triangles, day 2. I can apply theorems about isosceles and equilateral triangles to solve problems. Let's take a look at the proof that we ended up on yesterday, and it is about an isosceles triangle. It's about an angle bisector, over here angle bisector, and we know that this triangle on the right can fold onto the left. And when it does, we get this nice relationship about these sides or these parts being congruent, and that these two angles end up being congruent. Now, when those two angles are congruent, I said before, those two angles also have to add up to 180 because they're a linear pair. And the only way that'll happen is if they're both 90. So when this isosceles triangle gets folded on its angle bisector, we are going to get perpendicular, and we're going to get that angle bisector being a segment bisector. Let's take a look at the next slide, and we're going to talk about it again. I talked about this before. It's worth repeating. This triangle is going to fold onto the other side, which will force this to be congruent to this, and this angle to be congruent to this angle. So these two angles will be congruent. The only way that's going to happen is if both of these are 90 degrees. Let me go ahead and put that in green here. This is going to be a right angle. This is 31 degrees. This will be 31 degrees. If this is 31, this is 90, then this is going to be 59 degrees. So this angle will be 59 degrees, and PR from here all the way to here, remember this is 4 and this is 4, so this whole answer will be 8. Let's take a look at some new theorems: equilateral theorem, triangle theorem, and its converse. If all three sides are congruent, it's like a super isosceles triangle. So these two sides are congruent, therefore these angles are congruent. These two sides, therefore these two angles are congruent. These two sides, these angles are congruent. So they all end up being congruent because they're a super isosceles triangle. And the converse is true. If all the angles are congruent, then all the sides will be congruent. Let's take a look at a problem. So I know that this is CBD is 130 degrees. So that's 130. Now I know all of these angles here are congruent. This angle, and this angle right here. They're all congruent. Remember, they all add up to 180 degrees. Divide by 3, so each one of those angles is 60 degrees. So let's go ahead and write that down. This is 60 degrees. Now if that's 60 degrees, remember 60 plus what equals 130. And we know one of those angles is 60, so the other angle has to be 70. So this angle right here has to be 70. All right, if this angle is 70, remember we're working with an upside down isosceles triangle. We know that all three angles have to add up to 180. We know that that angle is 70, and these angles right here, this one I'll put a 3, and this angle right here have to be congruent. And if I don't know what they are, I'm going to call them x. So then this will be 2x is equal to 110, and therefore x is equal to 55. So what's a measure of BAD? BAD is equal to 55 degrees. Let's take a look at this one. These two angles are 60, and remember that has to add up to 180. So 180 take away 120 is 60. So this is a super isosceles triangle. It's called an equal angular triangle. And when all the angles are the same, all the sides are the same. So this will be equal to 12. Now all the sides are congruent, therefore all the angles are congruent, and all the angles have to be 60 degrees in order to add up to 180. And so this answer will be 60 degrees. Let's take a look at this is equal angular, which means that all the sides will be the same. So when all the sides are the same, we'll write 2x plus 11 equals 6x minus 9. We're going to subtract 2x on both sides. So we're going to get that. We're going to add 9 to both sides. So 4x equals 20. And then we're going to divide both sides by 4. And so therefore the answer is 5. Over here, this is 60 and 60. This has to be 60 in order to add up to 180, which means all the sides are the same. So I know this side and this side and this side are the same. So I'm going to set 2y plus 6 equal to 4. 2y is equal to negative 2. Therefore, y is equal to negative 1. So if I put a negative 1 in here, that answer will be 4. So that looks like it's reasonable. I'm going to set 5x minus 3 equal to 4. Add 3 to both sides, and that's going to be a 7. And then x will be equal to 7 fifths. All right, and if I put 5 times 7 fifths minus 3, and if I reduce, I'll get 7 take away 3, which is 4. So we know that answer works. So the concept summary is if two sides of a triangle are congruent, then the angles opposite those are congruent. If two angles of a triangle are congruent, then the sides opposite are congruent. If all the sides are congruent, then all the angles are congruent. If all the angles are congruent, then all the sides are congruent.